Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Right, thanks again, Sia, for keeping me awake all night. So this is question 4 of paper 2024 AS paper 2. So figure 13 shows an arrangement used to determine the thickness of metal foil using interference of light. Two thin glasses are separated by a foil at one end. Monochromatic light is incident on the glass plates from above. Tired just reading this, that's why everyone hates you, AQA. Figure 15 shows part of the arrangements where a bright fringe occurs. The angle between two plates called... Okay, right. So the plates are parallel to each other. Light rays travel perpendicular. Okay, so some of the light is reflected at O. Okay, the remainder of the light is transmitted through the gap. So it goes all the way down and comes back up. So that's a total distance of 2D. Okay, reflected light from A combines with O. Okay, at O there is a phase difference between the reflected light from A and the reflected light from O. The phase difference is caused by the path difference, which is 2D, and the reflection. Now, because at O there is a phase difference between the reflected light from A, and at A the phase of the light that is reflected is changed by 180. Now, 180 means n plus a half lambda. Okay, so at O there is no change to the phase of the light that is reflected. Oh, seriously, turn into an English exam. The thickness of OA of the air gap is D. All right, okay. So deduce the relationship between D and the wavelength of light that produces a bright fringe. So bright fringe, constructive. Okay, so what does that mean? It arrives in phase, or the path difference is n lambda. Now, what is it that's actually equal to n lambda? So what you've got something is equal to n lambda. Now you've got the 2D plus the half lambda. Okay, so let's take that to the other side. So 2D is equal to n lambda minus lambda over 2. So if I take the lambdas out of that, so 2D is equal to, let's see, n minus a half lambda. Okay, so that's how you would answer that bit. It's a bit weird. There's a lot of reading in there, so that sort of puts most people off. So let's move on to the next bit, hopefully less reading. Right, okay, so figure 16 shows a small part of the fringe pattern as viewed from above. The distance between the center of one bright fringe and the center of the next bright fringe is S. Okay, so they're telling you distance from there to there, that's equal to S. All right, so the thickness of the foil is T, and the length of each glass plate up to the edge of the foil is L. The thickness of the foil, okay, so it can be shown that T over L is lambda over 2S. Determine T using figure 16. Okay, so you got this formula. T over L is equal to lambda over 2S. They're giving you lambda, they're giving you L. We've got to work out T, so we've got to determine S from here. Okay, so let me just rearrange this first. So T is equal to lambda L over 2S. So clearly we're going to have to work out S from here. So the issue you got here is if you went from the center of the bright spot to there, you've still got some overlapping here, and you've got this overlapping there. So I'm going to do it from the center of this to there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 in 5 millimeters. So one of them is, so S is 5 millimeters over 11. So let me just put that in my calculator. So that gives me, let's see, 0.454. So 0.454 5 millimeters. So just got to be careful when I put millimeters into the next bit. So nanometers, centimeters, and we want T. So what is T? All right, so let's put everything into meters then. Okay, so we've got lambda, which is 590 times 10 to the minus 9 times L, which is 0.06 over 2 times, and what was it again? 0.45 millimeters. So 0.45 times 10 to the minus 3. And when I put all that in, I get 3.9 times 10 to the minus 5 meters. So which have I converted? So last bit, space between the plates is now filled with water. It was previously air. So the same light source is used. T and L remain the same. So let me just write this formula again. Where's it gone? T L lambda over 2s. So T over L lambda over 2s. So did you say the distance s will change when the water fills the space between the plates? The refractive index of water is 1.3. And it's asking about S. So what I'm going to do, I'm going to rearrange 4S. So S is equal to, excuse me, S is equal to lambda L over 2T. Now they've told us T and L remain the same, so I'm not interested in them. I'm not interested in T. So S is proportional to lambda. Now what do you know? Water, the speed in water is lower than air. So that means because frequency is constant, and what's the relationship between this and lambda? V equals F lambda. Then lambda decreases also. And so because S is proportional to lambda, that means S decreases. Okay, so that's that question.